Okay, here we have a pendant that hangs from two chains. So our two chains are here. They make a 90-degree angle to each other. And on the left side is 4 newtons. On the right side is 3 newtons. And we want to find the weight of the heart pendant. So what we have here is we can see that we have our right angle triangle here. I'm just going to draw in my axes. So I'm going to draw them in red straight down here and straight across. So we want to find the weight of the pendant which is going to act in this direction here. So I'm going to call that X, and that's going to be my vector C. And then we have to find a couple of angles. So we've got this right angle triangle happening here. So I'm going to call this alpha, and this here with the x-axis will be alpha as well because of alternate angles here. So these two lines are parallel, and the same happens for the other side. So this side here I'm just going to call theta, so that side is theta as well due to the Z rule that you would have done. Okay, so I'm going to call this A, and I'm going to call this one B. Okay, so I'm going to find alpha first. So I'm going to find, so alpha is just the inverse tan, so just working with your right angle triangle. Inverse tan, opposite over adjacent, so opposite over adjacent, so it's 4 over 3. And you'll get alpha to be 53.13. And then all angles add up to 180, so I've got 53.13 plus 90, and then take that away from 180, and theta is 36.87 degrees. Now I can find my individual vectors. Okay, so here I have my vector A, so I'll just change my cursor here. So vector A, -4 cos of the angle there. We found the angle down here. So we're negative because we're on the negative x side, and that's our magnitude, which is 4. Trying to find the I component, which is cos of that angle there, plus 4 sine of that same angle will get you the j component. Same goes for vector B, except we've got a magnitude of 3n, and our angle there is alpha, which we found to be 53.13. So finding I and j, they're both positive. And then we've got C, which is -x in the j direction only. So now, because the pendant's hanging there, so it's stationary, A plus B plus C equals 0. So all I'm worried about is trying to find that x. So just looking, I'm just going to do my j components. So evaluate your j components, and you will get 4 sine 36.87 plus 3 sine 53.13 minus x equals 0. So x equals this plus this, and you will get C to be 4.8j, okay, which is, if you want to convert it to kilograms, you divide by 100, so it is 0.48 kilos, which, yes, is a very heavy pendant.